Hi, I'm Odumba Patkar and welcome to this lecture on the module corrosion. We were talking about the types of electrochemical corrosion, and in last two lectures we talked about first two types of electrochemical corrosion, which are galvanic cell corrosion and concentration cell corrosion. Now in this lecture we are going to focus on the third type of electrochemical corrosion, that is peating corrosion. So let's see what it is. Peating corrosion or peating is a form of extremely localized corrosion that leads to the formation of small holes or peats on the metal surface. Peating is usually the result of breakdown of or cracking of protective layer on the metal surface at specific points. This gives to the formation of small anodic area and large cathodic area. In proper environment, this produces corrosion current. This peating corrosion can be explained by two ways. In this example, as you can observe, here's the iron metal on the surface of which there is a scale is produced, or dust particles or sand particles are accumulated. And in this case, metal surface which is below this sand or dust particle, which is less in contact with the oxygen or less oxygenated area, will behave as anode, and the rest of the metal part which having more connected or in presence of oxygen will behave as cathode. Now, as there is a very small anodic area which is below this dust particles, corrosion takes place at very small part, and as there is very large cathodic area, requirement of electrons on the cathode for reduction reaction is more, so more amount of electrons will be drawn from anode by the corrosion reaction. As you know, on anode the reaction is oxidation or corrosion, where metal goes into the solution form. Here in case of iron, the reaction will be Fe gives Fe2 plus ions plus 2 electrons on the anode, that is dissolution of metal, and these electrons will be transferred from anode to cathode, and on cathode reduction reaction takes place. Here the absorption of oxygen, it is half of O2 plus H2O plus 2 electrons gives 2 OH minus ions, and in between anode and cathode the ions will diffuse in the solution. From anode Fe2 plus ions and from cathode 2 OH minus ions will diffuse in the electrolyte, and that will produce the corrosion product, that is ferrous hydroxide, as like this. And as you can observe, the more requirement of electrons because of the large cathodic area, so that electron requirement can be fulfilled only by corrosion reaction on the anode. And as there is very small anodic area, so corrosion takes place on that small anodic area at very faster rate, and as you can see there, the small pits or holes will be formed on the metal surface on that small anodic area. So this is the one way to explain this mechanism. In the other way, we can explain the same mechanism using this example. Here the metal is protected by using the oxide layer on the surface, but if this oxide layer is break somewhere, in that case this small part of the metal which is directly in contact with the electrolyte will behave as anode, and the larger part of the metal which is not directly in contact with the electrolyte will behave as cathode. And in this case, again, because of the small anodic area, the corrosion will take place at the small anode, and what we can observe, that is the peats formation on the metal surface or holes formations on the metal surface because of the corrosion at very localized area. And electron requirement on the cathode is more. So in either way you can explain this mechanism. So remember, on the anode, which is very small in this case, corrosion reaction takes place, hence peats are formed on the metal surface. And on cathode, always reduction reaction takes place, and that will be, of course, depends upon the surrounding electrolyte. That may be either evolution of hydrogen, if that is acidic electrolyte, or that may be absorption of oxygen, if that is neutral aqueous environment. Question can be asked like, write note on beating corrosion, that means for 3 marks or 5 marks. So you need to write what you mean by beating, explain the mechanism with the help of reactions, and of course you need to draw the diagram to explain this mechanism. Either of the diagram you can draw and explain the mechanism. In the next lecture we'll talk about next type of electrochemical corrosion. So that's it for now. Thank you very much. See you next time.